formation takes place simultaneously. Hence, it is called as a concerted type of reaction. Now, here we are going to see the how or why the backside attack of the nucleophile takes place. And whenever backside attack takes place, what will happen to the stereochemistry? Now, here the mechanism I already told you. This OH negative approaches from the backside. See, therefore, the Ingold scientists suggested that this nucleophile approaches on the substrate from the backside. CBR bond. This is a CBR bond. CBR or CCl bond. Okay. Only halide I have changed. Only halide instead of Br. I have taken Cl here. In three-dimensional view, I have taken the Br. Now, therefore, approach of the nucleophile takes place from the backside of the CBr bond or CCl bond. Then, due to this, what happening? Whenever OH negative approaches from the backside, there are only 3 small hydrogens are there. Therefore, attack of the nucleophile from backside will be easy. There will be no steric hindrance because whenever OH negative approaches, there are only hydrogen. Therefore, there is no steric hindrance whenever OH negative approaches from the backside. And as there is no steric hindrance, the less energy will be required. Therefore, it is energetically favorable reaction. Backside attack is energetically favorable in case of SN2. If suppose consider this OH negative will approach from the front side. See this OH negative approach from the front side. What will happen if in this case suppose Br negative, this Br negative, OH negative is your nucleophile and this is Br is a leaving group. The OH negative whenever approaches from the front side, on the front side of the carbon, the OH, let us consider this red spot as a OH negative having the negative charge. Br is also having the negative charge. Therefore, both are having the negative charge. Therefore, there will be the dipole-dipole repulsion between the Br and the nucleophile, that is OH negative. Therefore, high energy will be required due to the repulsion. Energetically not favorable. Also, second point is that whenever it approaches, OH negative approaches from front side, OH negative is also bulky. Br is, as you see, Br is also bulky in nature. Due to that, both are bulky in nature, both are having negative charge, and due to that, there is a strong steric interaction between these bulky groups. Therefore, here, whenever front side attack is there, you have to consider 2 points, that there is a dipole-dipole interaction between the OH negative and Br negative, as well as there is a strong steric interaction due to the bulky nature of the OH negative as well as Br negative. Therefore, due to the dipole-dipole interaction as well as due to steric interaction between the OH negative and Br negative, the very high energy will be required. It is energetically unfavorable, and due to this, the front side attack of the OH negative is not possible at all in case of SN2. Therefore, only backside attack of the nucleophile is energetically favorable. Hence, in SN2, only backside attack is possible. Now, whenever we are going to study the energy profile diagram, in this case, you can see here the graph plotted energy versus the reaction coordinates of the SN2 reaction. In this case, you will see here the starting material is Rx. Now, this is your starting material, alkyl halide nucleophile. Then it gets converted into one step into the product. Nucleophile gets attached to the R and X will use as a X negative leaving group. But this reaction taking place one step but taking place through the transition state, and transition state is indicated here. Here 3 R groups are there. Here we are taking CH3Brs or CH3Cl. Therefore, these R are the hydrogens. But these 3 R groups form a covalent bond, while the nucleophile is going to attack from backside. Therefore, it is shown by dotted line. This bond is going to form new, and simultaneously the CBr bond or CX bond is going to break. Therefore, these bonds are shown by the dotted line in transition state, while these 3 are attached to the carbon shown by the covalent bonds. Therefore, this carbon is surrounded by total 5 atoms, 3 R groups, 1 nucleophile and 1 leaving group. Therefore, this transition state is very much crowded, pentavalent, and therefore immediately it will bring to give the product. Therefore, products are more stable than the transition state. Immediately, transition state breaks to give the product. Actually, in mechanism it is shown like this. Instead of CBr or CCl, I have taken here iodide. Means ethyl iodide as a substrate, OH negative as a nucleophile. When a backside reaction takes place, transition state will be formed. Now here three hydrogens are there and one OH and the pentavalent transition state is there. Having the negative charge, this crowded transition state immediately break to give the product. In product, the OH negative approach from the backside, therefore the molecule get inverted and this OH negative will attach and I will give as a I negative as a leading group. Therefore this is energy profile diagram. It is only one step reaction. Starting gives the product through the transition state. Now we are going to consider how in detail the transition state look like. See here. Here it is shown that this whenever transition state we are considering it is a pentavalent. Just now I told you three hydrogens CH3Br or CH3Cl. One is nucleophile and another is leading group. Therefore the new bond between carbon and the nucleophile therefore it is shown by dotted line. Similarly the carbon and the leading group new bond, this bond is going to break, therefore it is also shown by the dotted line. Whole transition state having the negative charge because this OH negative having the negative charge and leading group also having negative charge, therefore overall that is shown on the square bracket negative charge. This transition state is a pentavalent and therefore very much crowded transition state. 5 groups are attached. These 3 hydrogens are attached by covalent bond and these are attached by the dotted lines, means partial bonds. Therefore, pentavalent transition state very high energy required energetically, unfavorable, therefore it will immediately break. Now, in this case, whenever backside reaction takes place, then we have to consider the stereochemistry of this. Therefore, we have to show or prove that it gives the inversion of configuration. When you will show the inversion of configuration, how to show it? Therefore, basic thing is that if any reaction is carried out, then if the product having the configuration opposite to that of the reactant, then it is said to be proceed through the inversion of configuration. Therefore, for that to prove stereochemical effect, we have to take the optically active compound. That means the substrate must be optically active, having either R or S configuration. Therefore, the groups attached to the carbon must be all 4 groups must be different. Then it becomes a asymmetric carbon. Then it will show the optical activity. Therefore, here the 4 different groups are, one is hydrogen, another is CH3, another is ethyl group, and this is CPR. Now, whenever this optically active compound having the configuration S, 2-bromobutane. This is your starting material to prove the stereochemical evidence. You have to take this optically active compound. OH negative approaches from the backside, then simultaneously CBr will you. Therefore, you have to show the transition state as these 3 groups are covalently bonded while OH negative and Br negative are shown by the dotted line. Don't forget to write the negative charge also on the square bracket of the transition state. Now, whenever backside attack takes place, the whole molecule gets inverted. Therefore, here in product will get inverted. And as OH negative approaches from backside, therefore OH negative join by from the backside. What is happening due to the inversion of configuration? This molecule gets inverted. Therefore, starting having the S configuration, the product must having opposite configuration. Therefore, product having the R configuration because these all groups gets inverted. Due to that, opposite configuration will be obtained, that is R. Therefore, starting having S configuration, product having R configuration. This proves that in SN2 reaction, there must be the inversion of configuration. This is the experimental proof of the stereochemical evidence. Thank you, dear students. Now, in next, we'll continue this by considering the